Good afternoon and welcome to our presentation on our Ag Aid summer internship at Innovate Ag. My name is Mia Hargrave. I'm from the California Central Valley and I am a rising senior at the University of Washington, studying geography with a concentration in data science as well as a minor in information systems.
Hi, my name is Josh Bailey and I'm from upstate New York. I'm a rising senior at Purdue University studying agricultural economics and focusing in ag tech. Over the summer, Mia and I interned at Innovate Ag, a Walla Walla, Washington-based ag tech startup and Microsoft partnered company, and also one of Ag Aid's core partners. Innovate's tagline is empowering growers with data, and is focused on acting as a data processor and provider for farmers by interpreting results from various data collection systems. Farmers face several issues that keep them up at night, and top examples are thinning off the right amount of the crop through chemical and hand techniques to get the ideal size and count of apples in order to increase profitability, labor planning and ensuring the right amount of people are present and at the right place at the right time, projecting harvest yield for logistics planning during harvest season, and the general question of how are we managing variability.
With new technologies coming to agriculture, growers are faced with an explosion of data across silos and struggle to synthesize how the data can be used to their benefit. However, having all this data requires follow-up steps. First, aggregating data across multiple sources, then interpreting data in a meaningful way. Next, relating the information back to farmers, and last, showing the value of the data collected. We've made it our goal to take these massive amounts of data and put them into a form that's understandable and allows growers to make data-driven decisions about their crops. Through our internship, we wanted to create understandable, actionable information, as well as a place to find all this.
Also, to clarify, the source of the data you'll see visualized in the presentation is collected from the Green Atlas Cartographer. This is a UTV-based system that is driven up and down rows and captures data on the crop and trees to be used for analysis. Scanning of blocks is done as early as May through the harvest season 2+ times.
In order to present information in a meaningful way for growers, I've used Tableau to aggregate data from across Innovate systems onto a singular interactive dashboard. Here, a grower can access information from all time in one convenient place. They can make decisions around labor, spraying, irrigation, etc., based on the data from the history of their crop, as well as analyzing trends from the current moment. I've programmed in some interactive capabilities, as well as that to select what periods of time to look at. Different scans. Selection. Tooltips and on. Another capability that I want programmed in the future are means for growers to assess when a crop is at risk of developing disease. And this can be done through a visualization of temperature and humidity at different points in an orchard. But for now, I just have the temperature at a singular point. An end goal for this would be to see it on a map and see changes at different points in an orchard.
From an economic standpoint, a lot of time was initially spent talking to farmers about the scanning reports and their operations and what additional tools would really help in connecting the dots. From our talks, 3 key areas relating back to farmer and data issues were identified to address given current technology. These are creating relatively accurate predictions for yield in a block and correlating to packout, tracking how much it costs to produce a bin of apples historically, and understanding the financial value of the scans provided. Starting with predicting yield and looking at optimal packout for harvest, the Green Atlas system has tremendous ability in being able to show the map variability of sizes, and this variability can be thought of as a histogram to portray the size distribution. However, this distribution is reflective of when the scans took place. What if they were taken in June or July, much before harvest? The idea of this yield prediction tool is that farmers can predict how much they think this histogram will shift by the time of harvest, and after making some assumptions, get a prediction of yield at harvest. These outputs can also help growers determine optimal hand thinning and labor decisions to possibly adjust the histogram in favor of better sizing. From there, the best packout estimate section serves as a way for the farmer to check how well they're achieving the best packout price possible so far based on size correlation and an assumption of quality at the highest grade. This serves as a benchmark and helps a grower see how well they're hitting the best price possible for their fruit. Overall, this tool will be integrated as well into the dashboard and can help farmers create and provide better yield estimates so downstream the value chain can prepare and make adjustments accordingly. For the next part, to track how much it costs to produce a bin of apples historically, I made a model based on research done by Dr. Karina Gallardo for how growers could input and visualize their variable costs for a specific block and compare over time. The idea was to allow growers the ability to see what they were spending more or less on each year based on the block and correlate that to the number of bins produced in the block in the given year. At the same time, they could compare these costs to the pack-out data collected from that year to see differences in profit per bin. However, this seemed too academic for application given current widespread labor tracking methods, so the focus became more on understanding how the variability in a block is affecting the farm at the economic level, and how using data collected from Green Atlas scans can help manage it. The goal in managing a block of orchard is to produce the best size and quality of fruit at a uniform level at the lowest cost possible. Therefore, understanding the coefficient of variability is absolutely critical. The goal would be to reduce that coefficient of variability in each block as much as possible, essentially narrowing the histogram, and this would be done by managing labor and resources in such a way that the degree of intensity applied to certain areas is based on the relative need determined by scans provided. For instance, if it was determined from a scan that there was higher blossom density in certain areas than others, more chemical thinning treatment could be applied in general there than those with less density, providing cost savings for spraying at a more efficient level and later leading to greater uniformity. This is where the value of the scans can be determined. By collecting the data and acting upon it, uniformity and ultimately higher profits can be derived from management decisions such as these.
So, in the scope of our work, we've created a tool to provide customers of Innovate Ag that makes decision making simpler. This said, in the future of autonomization of agriculture, we believe that all growers can benefit from technology such as this. And we hope that someday it can be in the hands of many, so that all growers may be able to conveniently make educated decisions for their blocks based on easily readable visualizations and economic data.
By relating the data provided to growers as part of the goal of maximizing profits, the value of the data collected is much more comprehensive. Tying this back to Ag Aid, understanding variability and how to manage it is the basis for understanding how to deploy water intelligence, farm intelligence, and labor intelligence, while modeling systems of knowns and unknowns to drive each of these. All of these together will help empower growers to greater future success.